So today I will be talking about computer networks stop and wait protocol. So this is a very small topic, and obviously this is a protocol which uses the ARQ based method. So what is ARQ? Let me tell you. ARQ stands for automatic repeat request. So what this really means you will get to know in this video. So whenever we are sending anything on the internet, there are two entities, the sender and the receiver. So whenever, let's say, we have to send a file which has a very large size, let's say 3 GB. So we are not directly sending the packet in one go. What we do, we divide the whole packet into small chunks and we send them one by one. So we have a sender and we have a receiver. So let's say our data size is 500 bytes. 500 bytes. And our packet size is, we have decided to send only 100 bytes each. So we will be requiring 5 packets total. 100 bytes because this 100 yes and these. So finally 500 bytes of data will be sent from the sender to the receiver side. So how this stop and wait protocol works, let me tell you. The sender sends the first packet. When receiver receives the first packet, it sends the ACK. And ACK stands for acknowledgement. Basically, it acknowledges that yes, this packet has been received. So let me tell you one very important point, that many standard books and authors use ACK 1. If packet 1 is sent, then ACK 1 is sent from the receiver. And many authors use this method, that if packet 1 is received, then ACK 2 is sent, and it's basically the number is for the packet for the next packet which is to be sent by the sender. So GATE exam follows this method, so we will be following this method, and I think I have made myself clear. There is nothing to confuse about this numbering. Basically the number is for the packet which we are requesting. So this is what automatic repeat request. We are constantly repeating the request, like when packet 1 is received, then we send the ACK for 2, and when packet 2 will be received, then we will be sending ACK 3, and in this fashion the last packet 5 will be received and ACK 5 will be sent by the receiver to the sender. So that's why it is repeat request. So after packet 1 is sent, ACK 2 is received, and then ACK 2 is received, packet 2 is sent by the sender to the receiver, and for this the receiver sends ACK 3. But there can be two conditions which can happen. And this is a very crucial part, let me talk about this. So what happens, that what if the packet 1 which we are sending, this got lost. It never reached the receiver, and this can happen due to multiple reasons. Let's say the channel which we are using, it's very has a very heavy load, has a very heavy traffic, and that's why the packet got dropped. Or when we are sending files in a very we're sending very long distance nodes, then the packet travels to multiple routers, and what if in between any of the routers, in the queue memory there is no space to store this packet, so the router will drop the packet. So we will be talking about these points in our further videos in great detail. Let's stick to this for now. So packet 1 is lost. So as packet 1 is lost, no ACK2 is generated by the receiver. So how we are going to handle this condition? What we do, the sender decides a time that within this time, if I didn't get the ACK, I will retransmit the same packet. So let's say at t is equals to 0, the packet was sent, and the time which was decided was t, that after this t time, if I didn't get the ACK, I will do the retransmission of the packet. So as we know that packet 1 got lost and no ACK received, so after this time, packet 1 is again retransmitted. Packet 1 is retransmitted, and for this, when it is not lost, the receiver gets the packet 1. So receiver sends ACK. What is the next packet which the receiver wants? Which is packet number 2. So it sends ACK 2. So packet 1 is received, ACK 2 has been sent. So now the packet 2 will go. But what if this ACK itself got lost? Here the ACK got lost. So how this stop and wait protocol handles this? So again the same thing. It just says that if I didn't get the ACK, I will retransmit. So let's say at time t1, the packet 1 was retransmitted. Packet 1 was retransmitted. And when the ACK was coming, it just got lost due to the same reasons. So after t time, the sender will wait for t time. After t time, it sees that I have already sent packet 1 and I didn't receive ACK 2. I will again do the retransmission. Packet 1 is retransmitted. Is again retransmitted. And now when the receiver and now what happens, that receiver already has this packet 1, because we know that packet 1 was already received at this point. So the receiver drops the packet. What the receiver will do, the receiver will drop the packet, because it already has this packet, and it sends ACK2 again, because he knows that I want this packet number 2, not packet number 1. So this is how the stop and wait protocol works, and please do like the video if I have added any value. Thank you very much.